PRISCI Educational Academy welcome you all. Today we are going to know about the Stokes theorem. Definition of Stokes theorem is integral over C effector single integral effector dot dr vector which is equal to double integral over S del cross effector dot n cap ds. Let us solve one problem. Verify Stokes theorem for a vector field defined by effector is equal to x square minus y square I vector plus 2xy j vector is the rectangular region in the xy plane bounded by the lines x equal to 0, x equal to a, y equal to 0, y equal to b. So the limit is given, the vector field f is given. The Stokes theorem left hand side is single integral over c effector dot dr vector. First let us find left hand side. Single integral effector dot dr vector. Next we have to draw the diagram using the region bounded by the values are given x equal to 0, x equal to a, y equal to 0, y equal to b. As you are showing in the diagram, first x axis, next you have to draw the y axis. On x axis y equal to 0, on y axis x equal to 0. X equal to a you have to draw vertically, right? Horizontally you have to draw y equal to b. So the points are noted O, A, B, C, the corner points O, A, B, C. The point at O is 0, 0. The point at A is A, 0. The point at B is A, B. The point at C is 0, B. The point at 0 is or O is 0, 0. So single integral means line integral OA, AB, BC, CO. This is the line, closed curve, closed line, closed curve. Okay, so OA, AB, BC, CO, closed. So effector that is given in the problem x square minus y square into I vector plus 2xy j vector. Dr vector, r vector we know, r vector is equal to xi vector plus yj vector plus z k vector. So dr vector is equal to dxi vector plus dyj vector plus dz k vector. So effector dot dr vector is equal to, both we have to dot product. So x square minus y square I vector plus 2xyj vector dot dxi vector plus dyj vector plus dz k vector. So effector dot dr vector, I dot I will be 1, I dot j will be 0, I dot k will be 0, j dot I will be 0, j dot j will be 1, j dot k will be 0. So I dot I will be 1. So x square minus y square dx plus 2xy dy. So effector dot dr vector is equal to x square minus y square dx plus 2xy dy. O, A, B, C, the corner points, closed line is a rectangle. N cap we have to find. So N cap means unit outward normal vector. So unit outward normal vector for XOY plane is k vector. Unit outward normal vector for XOY plane is k vector. So next left hand side. So effector dot dr vector which is equal to single integral OA plus single integral AB plus single integral BC plus single integral CO. Let us find first along OA. Along OA, what is the equation? Y equal to 0. If y equal to 0 means dy differentiating with respect to y, it will be 0. dy is also 0. So single integral f vector dot dr vector is equal to integral x square minus y square dx plus 2xy dy. For y you have to apply 0. For dy also you have to apply 0. Second term 2xy dy, there is y dy, so 0. In first term there is x square minus y square will be 0, x square dx. So integral x square dx. How to find the limit? Along OA, at the point O, what is the limit? What is the point? 0, 0. At the point A, what is the point? A, 0. A, 0 means A is x, 0 is for y. At the point O, 0, 0, first 0 for x, second 0 for y. So along OA, the limit is for x, limit for x is first point 0 to along OA at the point A. So 0 to A. So therefore integral 0 to A x square dx, which is equal to x square if you integrate x cube by 3. So upper limit you have to apply first, minus lower limit you have to apply next. So a cube by 3 minus 0, so a cube. Next along AB, the same rule we have to follow. X equal to A, the point is x equal to A, the equation. Dx is equal to 0. So f vector dot dr vector is equal to x square minus y square dx plus 2xy dy. For x you have to apply A, for dx you have to apply 0. So first term will become 0 because the dx is there. In second term 2xy dy. For x you have to apply A, so 2ay dy. Next you have to see the limit for the line A to B. For the line A to B, at the point A, the point is A, 0. At the point B, the point is A, B. Here we have to find the limit for y. What is the limit for y? 0 to B. So 0 to B, 2ay dy. So 2a, y dy if you are integrating y square by 2, you got to apply the limit 0 to b. So 2 cancelled, so a b square. Next along BC, equation is y equal to b, dy is equal to 0. So integral f vector dot dr vector is equal to integral x square minus y square dx plus 2xy dy. For y you have to apply b, for dy you have to apply 0. So second term will become 0. First term x square minus y square, for y you have to apply b, x square minus b square, integral x square minus b square dx. Here you have to find the limit for the line B to C. B to C, you have to find the limit for x. X means first point A at B, at C 0. So A to 0. Lower limit is A, upper limit is 0. So integral A to 0 x square minus b square dx, which is equal to x square if you integrate x cube by 3 minus b square into tx if you integrate b square into x. Limit is A to 0. If you apply 0, two terms will become 0. If you apply the lower limit A, before applying lower limit A, you have to minus sign. So minus a cube by 3, minus of minus will be plus ab square. So third one is along CO. Here the equation is x equal to 0, So therefore dx is equal to 0. So integral f vector dot dr vector, both terms are having in the integration x, dx is 0, first term will vanish. In second term x is there, so second term also vanishing. So the answer is 0. Now you have to add all the 4 terms. Integral f vector dot dr vector is equal to along OA plus along AB plus integral along BC plus integral along CO. So 4 terms, the values are, 4 integral values are a cube by 3 plus ab square minus a cube by 3 plus 0. So left hand side f vector dot dr vector is equal to 2ab square. Take this equation number 1. Left hand side over. So right hand side double integral del cross f vector dot n cap ds. Del cross f vector, this is a irrotational type. So del cross f vector is equal to determinant I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, x square minus y square, 2xy, 0. So determinant, how to find the determinant value, everyone knows. So for example, I you have to take row wise, column wise, strike out the values. Remaining there will be dou by dou y of 0 minus dou by dou z of 2xy. In the similar way, you have to go for j. So minus j into row wise, column wise, you have to strike out, cross out minus j. So remaining is dou by dou x of 0 minus dou by dou z of x square minus y square plus k vector, row wise, column wise, you have to cross out. So remaining dou by dou x of 2xy minus dou by dou y of x square minus y square, which is equal to I vector dou by dou y of 0, 0 minus j vector 0 minus 0 plus k vector dou by dou x of 2xy. 2xy if you are differentiating with respect to x, 2y minus dou by dou y of x square minus y square. If you are differentiating with respect to y, you will get to minus 2y. Minus of minus 2y will become plus 2y. So therefore del cross f vector is equal to 4y k vector. Del cross f vector is equal to 4y k vector. Now double integral del cross f vector dot n cap ds. That's why we have got the result of del cross f vector. N cap already we know, k vector. So double integral 4y k vector dot for n cap k vector dx dy. So 4y k vector dot k vector will be 1. So double integral over the limit 0 to b, 0 to a, 4y dx dy. First you have to integrate the inner integral. What is the inner integral? 0 to integral over the limit 0 to a, 4y dx. So 4y. So integral 0 to b, 4y dx. If you are integrating x, the limit is lower limit is 0, upper limit is a into dy. So a minus 0. So a. In the next step, 4a integral 0 to integral over the limit 0 to b y dy. So 4a y dy, if you are integrating, you will get y square by 2. The limit is 0 to b. Upper limit b, lower limit is 0. So 4a, if you apply the upper limit, b square by 2. 4a into b square by 2, which is equal to 2ab square. Take this equation number 2. Already we have got the equation number 1 result of 2ab square. Both are equal, 2ab square. So left hand side is equal to right hand side is equal to 2ab square. Hence Stokes theorem verified. Thank you all.